My name is Lisa Gardner, and I will be presenting on ecological interface design. For this video, I'll start by providing an introduction to the topic, give you a little background on where this principle came from, and then a specific definition. And then I'll run through a little bit about the process and techniques for implementing this in applications. And then ultimately just the conclusion on why this is beneficial in different systems and references that I used. Ecological interface design was introduced about 25 years ago by the work of these two men at Riso National Laboratory in Denmark, and it was based off the principles of ecological psychology, but they didn't want to focus on just the environment of the workplace or the user interface of an operator with a system. They wanted to focus more on the framework for interface design of how the entire workplace operated with the user. So it is based off the skills, rules, knowledge framework and implements the abstraction hierarchy. So I'd like to take a look at this figure on the right, where you see ecology, human, and machine, and how all of these are operating around the interface. You have the human working with the mental model, and then the machine providing machine logic, ultimately providing this whole system interface. So in this, the workspace or problem space is integrated into the cognitive system per se. So instead of defining the system relative to the human and machine, this approach, the system is relative to its function with the operator. So the focus of the design is to reflect the constraints of the workplace in a way that's perceptive and visibly displayed to the user. The skills, rules, knowledge framework defines three types of behavior that are present when operators are processing information. It was developed by Rasmussen, and it helps designers take in all the information for the system and apply it to aspects of human cognition. So, ecological interface design, the framework is used to determine how the displays and interfaces can take advantage of perception and decision making that the operators are going through. So this helps the designers apply different cognitive resources that need to be devoted to specific aspects of the process. Ultimately, these three behaviors describe the possible ways in which the information can be gathered from a human-machine interface and how that is then extracted and understood. Another framework used to develop EID is the abstraction hierarchy developed by Vicente. And this is a tool that constructs models of the work domain. It's essentially a template with 5 different levels that can categorize the different constraints and sources of information that are within the system. So the example I provided here is a study done on Army tactical operations. And the 5 levels are described on the left. At the top level, there's goals, purposes, and constraints. This is just essentially how the system interacts with the external world. And then next, priority measures and abstract functions. This is the intended property and function of the system. Then general work activities and foundations. This is just general functions that must be implemented. Physical activities and work. It's the highest level that describes the actual physical properties. And finally, appearance, location, and configuration of material objects. At the lowest level, this is just the physical makeup of the system and ultimately what the user will see. EID can be applied in a variety of systems. Some examples I came across were computer network management, medical anesthesiology, military commands and control, and aircraft displays. So here you see the second figure of the dominoes tracker. this can be misconstrued as ecological design because the user is seeing the whole process, they're getting updates along the way, but in reality, this is more user interface. If the operator at the store had a whole system displaying updates on the oven temperatures, predictive models of when things were going to be done, or new orders to come in, maintenance that would be required, that'd be more ecological design. You can see in figure 1, this display is providing aircraft constraints visibly so that the operator can relate them to other constraints they see and can direct their attention onto the next actions that need to be made. All of these applications help with information processing. Because of the way the displays work, they help the user focus in on specific parts and make the decision making and response selection process shorter. Therefore, the interface is helping the user work through their short-term memory while also relying on their long-term memory to make well-rounded decisions. So I hope I have provided you with a good overview on ecological interface design. To finish off, I just wanted to hit a couple of the pros and cons that have already been mentioned. Starting with the cons, implementing this requires extensive studies on the users and the system and the machines, and the implementation can take a while. Additionally, there's lots of challenges that go with adapting the system, especially if it's an existing one. And the hope is that reaction times will increase in responding to different components of the system. Sometimes this is hard to manage because there are so many components into it. But then again, with the pros, it's based on the skills and rules. You're doing studies on the user and helping them make better decisions. It can be implemented with complex systems, hopefully simplifying it in the end. And these human-machine interfaces can be relatively engaging for the user, and give a good framework to then providing nice data visualization. And finally, it helps with signal detection. When there are different things that need to be noticed to the user, it's all on one display for the whole system. So it's a good overview for the whole process, and overall just really helps the user and the whole system. These are the different journals and writings that I used when creating this presentation.